In this question, we're going to look at the probability of Hannah completing 2 events in a row, one after the other. The first event is badminton, winning or losing a match. The second event is tennis, winning or losing a match. When we've got one event happening after the other, this is best represented on a tree diagram. So one event is going to happen first, then the other. The first one we'll deal with is the badminton match. This badminton match has 2 outcomes, either a win, she wins badminton, or loses badminton. So the probability of her winning badminton is given to us as 9/10. The probability of her losing, the total outcome must add to 1. Certainty is 1. So she either will win or will lose. That is certain in this scenario. So 9/10, to get to 1, I'm going to have to add another 10. So this is our first event. So badminton will be blue. Change colour for tennis. So tennis can happen either after she's won badminton or after she's lost badminton. So if she wins badminton, there is no effect on what happens in the tennis match. We call this independent events. Okay, the badminton match and the tennis match are assumed to be independent. So she can win the tennis match. The probability of that is going to be 2/5. She could also lose a tennis match. 2/5 to get to 1 will have to be 3/5. Now this exact same event can happen after she has lost the badminton match as well. Depending on what outcome she gets, it will not affect the tennis match because these are independent events. So our probabilities are going to be the same. So this is a complete tree diagram for the 2 events. Now the question asks us, now that we have the tree diagram, what is the probability that Hannah will win both matches? So there is only one outcome which gives us both of these. If we look along this line, this one wins badminton and this one wins tennis. That is the only outcome we need from our tree diagram. Sometimes it asks for multiple outcomes. If it asked us if it was one win, no matter what match, there would be multiple outcomes. But in this case, it's only one. So once we have that, we need to multiply the probabilities together. This will make the probability less. Fractions times each other will decrease that value. So in this case, we're going to do 9/10 times 2/5. When we multiply fractions, we multiply the numerators, the numbers on the top, and we multiply the denominators, the numbers on the bottom. So our outcome here is 18/50, 18/50ths. If we want to, we can simplify this. I'm going to divide this by 2. Divide this by 2. We're going to get 9/25. And that will be the probability of her winning both matches.